Welcome to the Copperfield Electric Podcast. You know, when most people think about building a new home addition or maybe a backyard guest house, their minds immediately go to the fun stuff.
Oh, yeah, the visual stuff.
Right. You think about the exterior paint colors or like the kitchen countertops or mapping out the windows to get that perfect morning light.
Absolutely. That's the exciting part of the build.
But beneath the fresh drywall, there is this invisible, absolutely critical heartbeat that dictates whether that beautiful new space is actually functional or just, an expensive storage shed.
Yeah, I mean, without a properly designed and rigorously calculated electrical system, all those beautiful fixtures are basically useless.
Exactly.
You can have the most stunning kitchen island in the world, but if the wiring behind the walls can't handle the load of a modern refrigerator running at the same time as a microwave, well, the space just fails its primary purpose.
And we are unpacking that exact invisible foundation in our deep dive today. We're looking at the electrical planning of accessory dwelling units, or ADUs as they're commonly known.
It's a huge topic right now.
It really is. And we are drawing from two incredibly detailed sources to get this right. First, we have an expert article by Renee Hernandez from March 25th, 2026. It's titled, How to Plan Electrical Wiring for a New ADU.
That's a great piece.
Yeah, and we are combining the theoretical blueprint from that article with the official boots-on-the-ground service guidelines from Copperfield Electric.
Which is perfect because Hernandez gives us the step-by-step logic of how to plan a project on paper, while Copperfield's guidelines show us the practical reality, like what actually happens when theory meets the strict building codes of the real world.
Okay, let's unpack this. Our goal today is to give you a shortcut to understanding how to power an ADU safely and efficiently. And we're going to do it without drowning you in technical jargon.
Please, let's avoid the jargon.
Right, because whether you're planning to build an ADU in your backyard for some passive rental income, or maybe you're carving out a space for aging family members, or honestly, even if you are just curious about the hidden mechanics of home construction.
Which is fascinating on its own.
It is. But understanding this electrical foundation is going to prevent massive, budget-destroying headaches later on.
And those headaches are often the single biggest hidden cost in a new build. I mean, electricity isn't just some modular feature you can easily adjust or upgrade as an afterthought once the framing is closed up.
Once the drywall is up, you're kind of stuck, right?
Totally stuck. The infrastructure has to be calculated flawlessly before the first hammer even swings.
So before we start pulling wires through the walls, let's establish exactly who does this kind of heavy lifting and where this building trend is exploding. Because the reality of this work is highly localized.
Right. It's very dependent on where you live.
According to our sources, Copperfield Electric is a family-owned business operating as a 24-hour electrician service, specifically out in Orange County, Southern California.
And their service footprint reveals just how widespread this construction boom actually is. Looking at their guidelines, they're covering residential, commercial, and emergency calls across a massive area.
Oh, yeah. The list of cities is huge.
It really is. They're including places like Irvine, Costa Mesa, Anaheim, Santa Ana.
It's a huge chunk of the county right there.
Yeah, and it keeps going. Mission Viejo, Newport Beach, Tustin, Huntington Beach.
Wow.
And they also cover Orange, Fullerton, and Laguna Beach. I mean, that is a massive operational radius handling this influx of new construction.
Which makes perfect sense when you look at the current housing landscape in Southern California right now. We are seeing a historic surge in ADUs.
Oh, absolutely.
But when you take a brand new, fully functional microhome and drop it into a typical suburban backyard, you are immediately confronting a unique physics problem.
Yeah, the structural challenge stems from the fact that an ADU shares the exact same plot of land as the primary residence.
Right.
And initially, most homeowners just assume it can simply share the exact same electrical supply.
Like just plug it in.
Exactly. But this expectation immediately stresses the existing electrical system of the main house. Because, that main house was engineered decades ago to power one distinct floor plan, not two.
I love how the Hernandez article frames this, actually, because building an ADU isn't just about putting up walls. It is fundamentally a complex math problem.
Yes.
And the absolute first step before any physical work begins is something called a load calculation.
What's fascinating here is that a load calculation is essentially a forensic audit of your future power consumption.
A forensic audit. I like that.
Yeah, because you have to mathematically calculate the total power demand for everything that will eventually exist inside that ADU. That means tabulating the draw of the lighting, the the major appliances, the heating elements, the ventilation, and the air conditioning units. And you have to assume they might all be running simultaneously.
I like to think of a load calculation like hosting a massive dinner party.
Okay, let's hear it.
So, your existing electrical panel is your kitchen. Normally, you cook for your family of 4, and your kitchen handles that volume perfectly.
Makes sense.
But an ADU is like suddenly inviting 20 extra guests over for a 5-course meal. You have to know exactly how many guests are showing up, representing your lighting, your HVAC, your appliances, before you start cooking, which is supplying the power.
Right.
If you just start throwing food in the oven without doing the math, you run out of burners, you burn the food, and the kitchen descends into chaos. Or, in the electrical world, you blow a fuse, overload the system, and create a serious fire hazard.
The dinner party analogy perfectly captures the logistics of demand. That's really good. But we can take it a step further into the physics of what is actually happening in the wires.
Okay, lay it on me.
Think of electricity flowing through a wire, like water flowing through a plumbing pipe. Voltage is the water pressure, like how hard the water is being pushed by the utility company. Amperage, or amps, is the volume of water flowing through the pipe at any given moment.
Okay, voltage is pressure, amps are volume. Got it.
Right. So when you add a second home to your property, you are drastically increasing the volume of water, the amperage you need to draw from the street.
Hold on, this seems like a place where a lot of homeowners might spot an unnecessary upsell.
What do you mean?
Well, let's say I'm pouring tens of thousands of dollars into building this ADU. Why can't I just buy a heavy-duty, commercial-grade extension cable, bury it in a trench from my main breaker box to the new building, and call it a day?
Ah, the DIY trench method.
Right.
Yeah.
Like, why do the Hernandez and Copperfield sources insist that we might need a totally separate meter, a massive panel upgrade, or a dedicated subpanel?
Well, let's follow the plumbing analogy to answer that. Running a massive heavy-duty cable from an older breaker box is like attaching a giant fire hose to a tiny bathroom faucet.
Yeah, that wouldn't work.
Exactly. The fire hose itself can handle a massive amount of water, but the tiny faucet physically cannot push enough volume through the system to fill it. Your existing electrical panel only has a fixed amount of electrical capacity, usually measured in total amps.
Okay, so if I have an older house...
If your house has an older 100-amp panel, you cannot force 150 amps of draw through it just by attaching a thicker wire to it. The main breaker will continually trip to prevent the internal bus bars from physically melting.
Oh, wow. So the bottleneck isn't the wire going to the backyard. The bottleneck is the metal box bolted to the side of the main house.
Precisely. And Hernandez details the structural solutions for this bottleneck. If your current service is mathematically lacking based on those load calculations we talked about, the primary solution is upgrading the main electrical panel to a 200-amp service.
And what's that actually involve?
It involves working with a utility company to bring a larger supply of electricity, a thicker pipe, to use our analogy, from the street grid right into the property. Once that larger volume is available, then you install a dedicated subpanel just for the ADU.
Walk us through the mechanics of that subpanel. How does it physically manage the load differently than just wiring the ADU straight into that newly upgraded main panel?
So a subpanel acts as a secondary, localized distribution center. You run one large, high-capacity feeder cable from the newly upgraded 200-amp main panel across the yard to the subpanel. And that subpanel is mounted on the ADU itself.
Okay, so it's physically on the new building.
Right. Inside that subpanel, the raw power is divided up into smaller individual circuits dedicated solely to the ADU's lights, outlets, and appliances.
Oh, I see. It creates a physical firewall between the two buildings.
It creates an operational firewall. Because think about it. If a tenant in the ADU decides to run a high-wattage hairdryer, a microwave, and a space heater all at the exact same time on a single circuit.
Which people definitely do.
Oh, all the time. If they do that, the local breaker in the subpanel trips, the power cuts out in their bathroom, but the primary residence remains completely unaffected.
That is huge.
Yeah, it isolates the electrical faults, it gives the homeowner significantly better control, and immensely simplifies any future maintenance.
Beyond just convenience, there is a legal reality here, too. The sources make it clear that you don't always get to choose your setup.
No, you really don't.
Depending on your municipality, local building codes might explicitly dictate whether you are even allowed to connect to the main panel with a subpanel, or if you are legally required to have a completely dedicated separate service line and a separate utility meter for the ADU.
And local authorities have the absolute final say. Building codes are drafted based on the specific strain on the local municipal grid, and those regulations completely supersede any clever design ideas a homeowner might have.
Okay, so now that we have the raw power sitting safely at the threshold of the ADU via the new subpanel, we face a new physics problem. How do we efficiently route that massive amount of energy into a tiny living space?
That's the layout phase.
Right, and the Hernandez article focuses heavily on designing this electrical layout, emphasizing that you have to map out all the outlets, switches, and fixtures before a single piece of drywall goes up.
Strategic routing is vital because not all rooms draw power equally. You cannot wire a kitchen with the same gauge wire or the same breaker size as a standard bedroom.
They just use completely different amounts of power.
Exactly. The sources specifically highlight kitchens and bathrooms as high-demand zones that require their own dedicated circuits.
Explain the why behind those specific rooms, because, a television in the living room is a massive electronic device, but it doesn't require a dedicated circuit the way a tiny bathroom outlet does.
It comes down to how different appliances actually utilize electricity. Electronics, like televisions or your laptop, use complex circuitry to operate on very little actual wattage.
Okay.
Kitchens and bathrooms, however, are filled with appliances that rely on resistive heating.
Yeah.
An electric stove, a toaster, a curling iron, or a hairdryer. These devices work by forcing electricity through highly resistive metal coils to generate intense heat.
And heat requires a lot of power.
Creating heat requires a massive, continuous volume of amperage. Those sudden spikes in demand require dedicated wiring pathways that won't overheat under the strain.
Because ADUs are inherently compact, efficient design isn't just a buzzword here, it's a structural necessity.
For sure.
Every single choice matters more when you are working within a 500 square foot footprint. This is where the Copperfield guidelines highlight a specific detail about efficiency, heavily recommending LED light-emitting diodes for these spaces.
The physics of traditional lighting explains exactly why LEDs are universally recommended now. Traditional incandescent bulbs are incredibly inefficient.
They get so hot.
Yeah. They waste a tremendous amount of electrical energy by radiating heat in order to make a tiny piece of metal glow. LEDs skip the heat generation almost entirely, converting electrical energy directly into light via a semiconductor.
Which saves a ton of energy.
In a compact ADU, where energy efficiency is a primary goal just to keep the load calculations manageable, LEDs bring significant, measurable energy savings. Copperfield actually notes this upgrade is a major factor for minimizing power draw for both their residential and commercial clients.
Here's where it gets really interesting, because planning an electrical layout is no longer just about calculating the draw for lights in a refrigerator. We are looking at the modern, evolving home.
Technology is changing everything.
It really is. Both sources strongly emphasize the concept of future-proofing. Hernandez points out that modern ADUs often include integrated smart home devices, and the Copperfield services prominently list panel upgrades and specialized installations for EV electric vehicle chargers.
The electrical demand of a property is never static. It consistently trends upwards as technology evolves. So planning for that growth during the skeletal framing phase of construction is a critical financial strategy.
And this next part is where people either save $10,000 or lose it. Planning for an EV charger before the drywall goes up is such a pro move.
Oh, it's essential.
Right. Because running the thick conduit and the heavy gauge wiring needed for a high-speed car charger through open wooden wall studs takes an electrician very little time.
Very true.
But if you try to retrofit that exact same system 2 years later, you are talking about a nightmare of tearing open finished drywall, patching, texturing, and repainting. You save an absolute fortune by laying the infrastructure early.
It is the literal definition of future-proofing.
Yeah.
You're building flexibility right into the bones of the structure.
Yeah.
Even if the current homeowner does not own an electric vehicle today, having a 240-volt receptacle pre-wired in the driveway or garage area adds immense, tangible, long-term value to the entire property.
With all of this incredibly complex planning, and I mean, we are talking about mathematical load calculations, understanding amperage versus voltage, upgrading to 200 amp services, wiring dedicated high voltage circuits, and future-proofing for EVs, the logical next question is, who is actually executing this wiring plan?
Well, the sources are aggressively clear and aligned on this specific point.
Because it is incredibly tempting to treat an ADU build like a weekend landscaping project. You watch a few detailed YouTube videos, you walk the aisles of a hardware store, and you think, hey, I can run some Romex wire through these 2x4s.
Please don't do that.
Right. But electricity doesn't forgive DIY learning curves, and both Hernandez and Copperfield strongly warn against taking a do-it-yourself approach to any of this wiring.
If we connect this to the bigger picture, building codes are not just bureaucratic red tape designed to annoy homeowners or inflate construction budgets.
No, they exist for a reason.
They are a literal safety net engineered from decades of past failures. Every single ADU project has to follow strict national and local building rules. These codes govern the exact gauge of the wiring, the specific type of circuit protection required for wet areas like bathrooms, and the strict installation standards required to prevent catastrophic system failures.
It is really about keeping the structure from burning down in the middle of the night.
Electricity is entirely unforgiving. A small mistake in wiring, say, failing to torque a connection tightly enough inside an outlet box, doesn't just mean a lamp flickers.
What does it actually do?
At a microscopic level, that loose connection creates electrical resistance. Resistance generates heat. Every time a high-draw appliance is turned on, that loose connection heats up, expands, and then cools down when turned off.
Oh, wow.
Over months or even years, this constant thermal cycling loosens the connection further, generating more heat, until it eventually reaches the ignition temperature of the surrounding wood framing.
That is terrifying.
It creates a hidden fire inside a sealed wall, long after the DIYer thinks the project was a total success.
And that terrifying reality is exactly why the professional is so valuable. Hernandez explains that licensed electricians handle the truly painful administrative hurdles that a DIYer would struggle with anyway.
Oh, the paperwork is a nightmare if you don't know what you're doing.
Right. Securing the proper permits from the city planning office and passing the meticulous, multi-phase local inspections. The electrician ensures that the homeowner gets legal approval and that the entire project stays compliant from day one.
Which ties directly into why a company like Copperfield Electric explicitly highlights their specific legal and professional credentials.
Yeah, Copperfield emphasizes that their team isn't just experienced. They are rigorously background checked, they are licensed, and they actually proudly display their specific state license number right on their public materials. It's number 1094740.
Yeah, transparency is important.
They are also bonded and they are insured.
Let's briefly unpack what those three terms actually mean for a homeowner's protection, because a lot of people don't know the difference.
Yeah, go for it.
Being licensed means the state regulatory board formally acknowledges their technical competence and their grasp of the current building codes. Being insured protects the homeowner from massive personal liability if a worker is injured on the property or if accidental damage occurs during the build.
Okay, then bonded.
Being bonded means there is a third-party financial guarantee that the specific work will be completed according to the contract and the codes, even if the company somehow fails to deliver. It effectively transfers the massive financial and legal risks entirely from the homeowner's shoulders onto the contractors.
There is one more detail in the Copperfield guidelines regarding how they operate that really stood out. They explicitly state that they operate on a principle of honest troubleshooting. They only diagnose a problem or recommend a fix if an issue truly exists.
In the skilled trades, accurate troubleshooting is a profoundly important business ethic.
Because if a homeowner has an older property and they are worried about whether the panel can handle a new ADU, it is incredibly easy for an unscrupulous contractor to just glance at the box and immediately say, oh, you need a total $15,000 system replacement.
Oh, it happens all the time.
But accurate, honest troubleshooting, actually sitting down and doing the mathematical load calculations we discussed earlier, might reveal that the core system has enough capacity, and the homeowner only needs a specific, targeted subpanel upgrade. Accurately diagnosing the math saves homeowners thousands of dollars in the long run.
Exactly. An expert electrician doesn't guess based on the visual age of the equipment. They calculate the total potential draw. They diagnose the existing infrastructure's real capacity, and then they engineer a customized system that meets the exact mathematical needs of the new space while adhering strictly to the safety codes.
So what does this all mean? We have covered a massive amount of ground today, tracing the invisible power lines from the street grid through the 200-amp panel into the ADU kitchen, all the way out to the EV charger in the driveway.
We covered a lot of wire.
We really did. If you are embarking on an ADU construction journey, let's distill the core takeaways for you. It all starts with the math. Demand accurate load calculations before any hammers swing.
Crucial first step.
Be fully prepared for the physical reality that you will likely need to upgrade your main panel or install a dedicated subpanel to safely handle the new volume of power. When designing the interior, you must plan smart, dedicated circuits for high-drain areas like kitchens and bathrooms.
And don't forget the LEDs.
Yes, use LEDs. And you should always future-proof the property's value by wiring for high-tech additions like electric vehicles early in the process. And above all else, resist the DIY temptation. Absolutely. Hire trusted, local, fully licensed professionals like Copperfield Electric to navigate the unforgiving safety codes.
It is a dense, comprehensive process for sure, but when it is engineered correctly from the start, the final result is seamless.
Mm,
But before we wrap up, there is one final, larger implication to ponder based on the trajectory of all this technology.
I'm intrigued. What is it?
Well, we've spent this entire deep dive discussing how to safely draw power from the primary residence to the ADU. But if these microhomes are already requiring us to rethink our electrical panels and lay heavy-duty conduit for EV chargers, consider how the ADU of the near future might evolve.
Okay.
Instead of simply being a drain on the primary property's electricity, future ADUs designed from the ground up with integrated solar panel roofs and advanced high-capacity battery walls might actually generate and store their own massive energy reserves.
Oh, wow.
They could effectively become a decentralized, localized power plant sitting right in your backyard, capable of feeding electricity back into your main house during a rolling grid outage. The robust wiring choices and panel upgrades you invest in today are really laying the essential groundwork for that kind of total energy independence tomorrow.
From an electrical burden to an actual self-sustaining power source, that completely flips the script on the potential value of an ADU.
It really changes the math.
That is definitely something to think about the next time you look out at the empty space in your backyard. Thank you so much for joining us on this deep dive into the hidden, highly charged world of ADU electrical planning. We hope this exploration gave you the foundational tools and the technical terminology you need to approach your next construction project with absolute confidence. Keep asking questions, keep planning ahead, and we will catch you on the next one.